Not so long ago, multicolor 3D printing was reserved for either the few brave souls willing to spend endless hours tinkering and tweaking, or users of specific ecosystems that were compatible with the readily available commercial systems. But no more. Today, there is a wide range of open source, multicolor, and even multi-material solutions to fit every printer, every budget, and every use case. From simple, easy to build, and minimalist systems for color swaps to cutting-edge, extravagant platforms that allow you to push the limits of FDM. The space is absolutely exploding with innovation. So in this video, we're going to have a look at the top 16 or more open source systems that allow you to print with more than one filament at a time. We'll look at what it takes to build them, what they cost, and just what they're capable of. So whether you're just getting started or you're a seasoned vet looking to take on your next big challenge, stick around because there's something in this video for everyone. Let's get after it. Before we get started, I do just want to mention that this video is the latest in a series where I highlight the most promising open source projects. Not to worry, you actually don't need to watch any of these videos in order, but if you haven't seen the last one where I looked at the most exciting open source 3D printer projects, then you can click up here to open that one in a new tab, but please don't leave this one because, algorithm. As always, links to everything that I mentioned in this video will be in the description below. Wherever kits are available, I will include affiliate links so you can help support more videos like these should you choose to purchase. And just one friendly reminder, if you do choose to build any one of these projects, it is customary to support the creator with a small donation or a Patreon subscription. All right, are you ready? Here we go, starting off with multicolor or multiplexer systems. So first off, let's talk about multicolor systems to add multicolor capabilities to your existing 3D printers. From adding multicolor capability to a store-bought printer, all the way to converting your custom printer to print multiple colors, these open source systems help you manage multiple filaments. Now most, but not all of them, do make use of a filament cutter to cut and then retract the filament, which is then purged through the same nozzle. And this means that unlike the more advanced solutions that we'll get to later on in the video, these systems do invariably produce different amounts of poop, but they are generally much more affordable and accessible. All right, here we go. Let's go ahead and start off our list with perhaps the simplest and least known option, which is the NightOwl by Morton Jonaschat. I'm pretty sure I'm not pronouncing that correctly, so I'm sorry, Morton. The NightOwl is an integrated dual spool filament switching system. In fact, it is unique in that it is the only system on our list with only two colors. The NightOwl is a perfect example of the beauty of open source hardware. It actually integrates multiple different projects and technologies, including Hartkay's dual Nightwatch, the Filamentalist Rewinder, and Armored Turtle's turtleneck buffer. The end result is a simple and universal filament switching solution. It also makes use of the ERB multi-material board, and it's available with an integrated cutter right on the unit itself, in case you don't want to add one to your toolhead. As of the time of recording, kits are only available from Triangle Lab, and they'll set you back somewhere between $60 and $112, depending on which options you choose. Note that, as with all of the builds, the prices that I'm going to be quoting do not include printed parts, which you should definitely just print on your own if you can. I'll leave a link not only to the kit, but also to my filament brand of choice in the description. The Pico MMU is a lightweight, simple multi-material unit by LH, or Lemur Hayes, creator of the LH Stinger project that I shared in the last video in the series. As the name suggests, the Pico is quite small and simple, allowing you to juggle 4 filament colors with just one NEMA 17 motor, a servo, and some bearings, as well as a bunch of printed parts. This project also includes a bunch of different hub designs and its own filament cutter for the Orbiter or Sherpa Mini toolheads, both of which we will discuss in a future video in this series, so do make sure that you subscribe if you haven't already. As for where this MMU fits in with the rest of the items on this list, I'd say that if you're looking to build a multi-material unit but are intimidated by some of the other designs out there, then this might be exactly what you're looking for. As far as I know though, there are no kits available just yet, but the BOM or BOM is relatively simple and widely available, so we'll link it down below. Just do note that you do need to add a buffer and splitter to your toolhead. If the Pico MMU sounds a little too rudimentary for you, you will want to take the next step and check out the Multimaterial Extruder, or MMX, by the team over at CN3D. The MMX draws inspiration from the Pico MMU, but it's designed from scratch with a number of crucial improvements, most notably to reliability. These include a straight filament path for smoother loading and fewer jams, gate releases that use magnets instead of springs, micro switches on all the gates, closed-loop GT2 belts, and Bondtech dual gears. What's more, the MMX offers an easier user experience thanks to the integration with the Happy Hair multicolor management software. They even have plans to extend it to 6 colors. All in all, the goal is to have an MMU that can be printed in 3 hours and assembled in just 1. To that end, CN3D is currently working on an easy step-by-step installation guide, which is coming out soon. We will link to some of their videos about the MMX below, and should you choose to build it, you can actually already pick up a kit with the control board and everything but the printed parts for just $64. Link down below. Similar to the MMX, we have the HTLF, or Happy Turtle Lettuce Feeder by Armored Turtle. Originally designed as something of a joke, the HTLF is a much simpler automated filament changer than the others that we'll see in a moment from Armored Turtle, and it was actually designed in a single evening. It uses a camshaft to engage the lane, and CAD files are provided if you want to scale it from 4 colors to more. Best of all, it is designed to work with the simple and easy to use AFC software by the Armored Turtle project, but not the more complex Happy Hair. Kits are already available from both Blue Rolls and Triangle Lab, and they'll set you back $84 to $121. The next step up in complexity is going to be the Tradrack by Annex Engineering. Like many of these systems, it uses a servo to switch filament paths, but what makes it stand out is just how fast and reliable it is. The system is modular, allowing you to scale up to however many colors you want. It's also built with speed in mind, designed to keep up with the high-performance machines running Clipper. The Tradrack is designed to work alongside a custom buffer system and can easily and affordably scale up to add many more colors. The Tradrack is also heavily integrated with Clipper macros and features, and it's well documented with firmware support. To the best of my knowledge, it works with Happy Hair, but it isn't quite as deeply integrated, so while it's not a plug-and-play setup, it is well loved by those willing to spend the time to dial it in. As of now, the only kits I was able to find are from Triangle Lab. They cost $100 or so and feature 14 channels as the default. Link in the description. Now, one step up from there in terms of both complexity and user experience, we have the Enraged Rabbit Carrot Feeder V2 and its integrated buffer system, the Enraged Rabbit Cottontail. This system, which typically is available with either 8 or 12 colors, also uses a servo selector and gates to switch filaments. It uses a belt-driven stepper motor to drive the filament, but there are plans to come out with a direct drive upgrade, and that might actually already be out. I need to check. Unlike the Tradrack though, it is deeply integrated into Clipper and Happy Hair. I actually did an entire series on this one, both live streams and multiple videos, sharing my experiences as I built it. While it is a very cool design, it is not for the faint of heart, and it takes quite a long time both to build and to calibrate before it works reliably. Personally, I never was able to get mine working reliably, and the people that I've spoken to that have succeeded spent about 60 hours or more getting there. But I know the team is always making improvements to the design to make it easier and more reliable. As of now, a 12-color kit will cost as little as $179.99 from Physek, including the buffer system, but that doesn't include a kilo or more of filament that you'll need to print it out. But hey, if you enjoy a challenge, then this one might just be right up your alley. If, on the other hand, you are willing to sacrifice the number of colors and affordability for an easier build and more reliability, then you are going to want to check out the Box Turtle, that thing, by Armored Turtle. This unit uses individual stepper motors, trays, and a buffer, and re-spoolers to handle up to 4 filaments per unit. But you can use multiple units in tandem if your budget permits. What's more, because this is open source and built on readily scalable 2020 extrusions, you technically can also extend it to print more colors. The Box Turtle is also the first system on this list which allows you to enclose the filament, which will be great if you aspire to doing multicolor PETG prints. From my experience, the build is significantly easier than an ERCF, but perhaps not as easy as a Pico MMU, which I unfortunately haven't had the chance to build. And reliability, by all accounts, is quite good. What's more, it is very deeply integrated into Mainsail with its own AFC Lite software, which is a lot simpler than Happy Hair. Here, again, I did a full video all about the Box Turtle here on our main channel, as well as a more thorough build journal type video on our second channel, and we'll link both of those in the description. If you haven't checked out our second channel, by the way, please make sure to check that out and subscribe because we have a lot of really cool content coming up there as well. But coming back to the Box Turtle, as I've alluded to before, all of these perks don't come cheap. The LDO Motors Box Turtle kit starts at $299, and that's before adding an enclosure or a filament dryer. Links are in the description though, if you do want to check it out. If you prefer having your filaments enclosed right out of the gate, or you want to print with 8 colors, then you might just want to check out the lesser known YAMMU, or Yet Another Multi-Material Unit by Zerge. Currently, the focus of this project is to support loading and unloading, rather than multicolor, but in the future, they do hope to add that as well. The project itself is strongly inspired by Voron, with a similar design language and the same 2020 extrusions. It uses 2 identical feeders and an enclosure, but unlike any of the other systems on this list, the design already includes a built-in filament dryer. Currently, the YAMMU is just gearing up, no pun intended, to release the first teaser, version 0.1. It's still very much in the testing phase, but if you have the skills to help them bring this project to fruition, it is a very exciting one, and I'm sure that they would love the help. And now the final boss, the most complex and sophisticated multiplexer system I've seen to date. Meet the 8-track Raven, a 4-spool automated filament changer that is scalable. Unlike any other system on this list, the 8-track uses cassettes, which are individual and modular filament enclosures that should one day allow for features like active filament drying. Unlike the rest of the entries on this list, the 8-track Raven is very much still in the alpha phase, and it's looking for alpha testers and contributors to help bring it to the next level. Still, with the team behind the Box Turtle driving its development, this is a promising project that I look forward to seeing come to maturity. Naturally, no kits are available yet, but we will link to the BOM down below. Now, if all that sounds way too prototypey and a little bit of a hassle, but you still want something that has been out in the wild for a long time and just works, do make sure to check out the 3D Chameleon. Back in the day, 3D Chameleon was actually a commercial product, but these days it's been fully open sourced. Now, I've seen the system added to lots of different printers, and it seems to work quite reliably. Unfortunately, the switch to open source also means that there are no longer any kits available, but if you do want to try it out, you can already download the STL files from their GitHub, and you can self-source all of the parts from the BOM and build it yourself. If you like the idea of the Box Turtle, but not the work required to build it, then you might just want to check out the Open AMS project. It allows you to take a standard Bamboo Lab AMS and connect it to any Clipper printer. Yes, you heard that right. You can hack apart a Bamboo Lab AMS and get it to work with any printer you damn well please. But to do it, you will need a new mainboard and a filament pressure sensor, which replace the proprietary Bamboo Lab boards. That will set you back about $85 for the pair, but once you've done that, simply install some new firmware and there you go. An enclosed AMS without the 20+ hours of labor. Pretty cool. Now let's switch it up 180 degrees from a way to make a Bamboo Lab AMS fit your open source printer to an open source AMS for your Bamboo Lab printer. If for some reason you don't like the Bamboo Lab AMS or AMS Lite, or you just want a fun project to learn how multicolor systems work, you should check out the BMCU AMS system by, I think 4061N? I'm not sure, I can't read Chinese. But anyways, this system allows you to print 4 colors on your Bamboo Lab A1 Mini, A1, or P1S. But do be warned, it is intended as a fun learning project, and it is not yet as reliable as the official AMS. It'll set you back just $78, and I will, of course, include a link in the description. All right, in a moment, we're going to switch gears again. No pun intended, and we are going to have a look at some amazing Toolchanger systems that allow you to print not just with multiple colors, but with entirely different filaments as well. But before we do that, we do need to thank this video's sponsor, which is Atomic Filament. After all, once you choose which of these systems is best for you, you are going to need some actual filament to test it and load into it and play around. Am I right? You gotta love that sponsor integration. Atomic Filament is American-made, high-quality filament that you can trust. Whether it's their beautiful PLA colors like Too Good to Be Blue, or their reasonably priced composites like carbon fiber PETG, or even their more engineering-grade materials like ASA, carbon fiber nylon, and beyond. Every spool is made in the USA with attention to detail and quality in mind. And their filament is 100% compatible with the AMS and other multicolor feeding systems. I also particularly love that they have eco-friendly options like 3.5 kilo jumbo spools of Melt Miser low-cost PLA that is perfect for using as infill or prototyping filament. And perhaps best of all, Atomic Filament is giving TNL subscribers an exclusive coupon just to try them out. So to save 5% on your order, visit the link in the description or scan the QR code on the screen right now and enter code THENEXTLAYER at checkout. Thanks again to Atomic Filament for making this video possible. Now, let's get back to the video. Toolchanger Systems. Whether you want to do true multi-material printing, multicolor 3D printing isn't enough of a challenge, or you just don't like the idea of having to waste huge portions of your material on purging, then a Toolchanger is the way to go. Here are some of the most prominent and exciting Toolchanger projects on the scene today. First and foremost, we have the wildly popular StealthChanger, which itself is based on the early TapChanger project. This project is based on a Voron 2.4 and uses the flying gantry to zoom up and pick up tools which themselves attach and detach using pins, bushings, and magnets. Leveling is done with a tap PCB, and it's compatible with a wide variety of toolheads such as the Stealth Burner, the Dragon Burner, the Rapid Burner, and more. Though this project is well documented and backed by a thriving community, it is not for the faint of heart. Building multiple toolheads, lining them up, configuring the macros, and managing the extra power draw are all factors that add both complexity and cost. While there are variants and remixes of the core concept for, say, a budget SV08 Toolchanger using the original toolheads, or my no limits 7-headed version that I've been working on with the help of CN3D, generally speaking, you're looking at purchasing 4 to 5 complete toolhead setups, including hot ends, extruders, toolhead boards, and much more. And that's after you already have the Voron 2.4 or Sovol SV08 as a base. Still, if you're looking for the ultimate flexibility in terms of multi-material printing and customizability, there really is no match for the StealthChanger. Currently, there is a kit available from Physek, and LDO Motors is hard at work testing their kits for the StealthChanger, which hopefully they're gonna release very, very soon. So we'll update the description below to include a link as soon as those kits are available. We'll also link to the playlist for the build series of my own CN3D powered Toolchanger. Another cool Voron-based Toolchanger project is the Daksh. Though this project is not nearly as popular as the StealthChanger, it's still an exciting and promising one. The Daksh is compatible with the Voron TRIDEX 1.8, 2.4, and even the Rattrig VCore 3 with a servoless mechanical locking mechanism inspired by the Prusa XL. It's fully 3D printed and assembled using off-the-shelf components. It features automatic XYC calibration and even has quality of life improvements such as intelligent tool heating management and status LEDs on each toolhead. I actually interviewed Ankur, the creator of the Daksh, on the Infill podcast a while back, and I will link to that episode in the description for those of you who are interested. To my knowledge, there are no kits available, but we will go ahead and link to the BOM in the description. If a complete Toolchanger is a bit too complicated or too rich for your blood, I get it. But that doesn't mean that you need to settle for single material printing like some kind of plebeian. Instead, you can look into an IDEX or independent dual extrusion system, such as the TRIDEX. Yes, I know, I already covered some Voron IDEX machines in the previous video, and those actually should have been in this video, but deal with it. As the name suggests, the TRIDEX is an IDEX machine based on the Voron TRIDEX, meaning that instead of a flying gantry, it's the bed that moves up and down. That frees up room on the gantry for 2 extruders, which move independently on X, but together on Y. In some ways, this is a compromise over a Toolchanger, being limited to 2 materials and all that. But in other ways, it offers some significant benefits that you just can't do with a Toolchanger, such as much faster material swaps. Unfortunately, mainline Clipper does not yet support the kind of classic IDEX perks of mirrored printing or duplication, but I believe that you can use the RatOS fork from the RatRig team to enable that, and if you do, it will give this machine some significant advantages over your standard Toolchanger. Best of all, the build is much more affordable than a full-fledged Toolchanger. Though ideally you would want to build a custom machine with a wider X gantry to make room for the tool heads and to preserve your build volume, theoretically all you need is to build an extra tool head on a normal Trident, which should run you like $40 or less plus the printed parts, hot end, and extruder of your choice. Just note that if you do it that way, you will only have 225 by 250 by 250 on a single toolhead mode, or 205 by 250 by 250 in dual toolhead mode. Come to think of it, I actually don't really understand how IDEX motion systems work, so if you're curious, let me know in the comments below and maybe I'll build one. For now though, I will link in the description to some StealthChanger kits from Physek, as well as the TRIDEX GitHub. Okay, so technically, this one isn't out yet, but I'm going to include it anyway, simply because I know that if I don't, with my luck, it will get published like the day before we're scheduled to release this video. First introduced at Smurf 2023, the Voron Phoenix is a monstrous 600 by 600 by 600 IDEX machine. There's really not much more to say. Max, the man behind the Voron project, being the perfectionist that he is, still has yet to publish it, and therefore, there are no kits available. But that hasn't stopped companies like Physek from making their own 600mm Voron derivatives in the meantime. I'll see if I can find some information to link you guys in the description to learn more about the Phoenix, because rumor has it the release is imminent and the team is just finishing up the build guide. But if you want to know more about the Phoenix, spam the comments with "Unleash the Phoenix" or something like that, I don't know. So there you have it, 16 or so multi-material 3D printing projects that you can build at home. If you like this type of video, do make sure to subscribe, because we've got the third part in the series coming up, where we'll be taking a look at some of the most exciting open source tool heads and extruders to take your printer to the next level. That's all for this week, but I'll see all of you on the next layer.